Welcome, everyone. I have not done this for a while for this class, so it's a little bit different. But today we're actually going to take some notes. So you guys have done presentations the last couple of days. You guys kind of learned about intertidal zones and kind of like a little bit of an intro to oceans. I'm sure most of you guys just kind of watched it, kind of read some of the things and filled out the Google Forms, which is totally fine. Realistically, I was just trying to get you guys a intro into what we're going to talk about. So today we're going to actually talk about like a little bit of my background when it comes to marine biology. And then we're going to move actually into just some basic notes about the ocean. So like what it means to have salinity, what is the temperature differences, all those different things. So far you guys have talked about intertidal zones. So you guys understand that tides mean that it comes up and it comes back down. So we have high tide and we have low tide. And then we also talked a little bit about the creatures that are found in those intertidal zones or in those tidal pools. So you guys kind of realize that there's a lot of biodiversity in just a small area that a lot of us would overlook. Typically, guys, when we think of the ocean, we think of things like clownfish, sharks, jellyfish, sea turtles. Okay, some of the things that we are more accustomed to because we've seen movies, or they're pretty, or they're kind of cool to us. Okay, but we have to realize that there's other organisms out there that are just as cool. They might just be smaller, or just might not be as known within the forefront of a lot of things. Okay. So I'm going to kind of talk about some of my background quick, and then we're going to get into notes. So my background in environmental science, but my background in marine biology is not very much. But there's a couple of things, guys, that is kind of cool that I had some opportunities to do in college and in high school. So when I was in high school, I went on this trip to Costa Rica with a program called Seeds of Change, which is the program we actually had here 2 years ago. Now, I was lucky enough that after my first year program, they had a turtle tagging trip in that winter. So I was able to go. Now, I went to their website today just to kind of see what they still have here because I know they still do this, but they haven't really updated their website in a lot recently. So I actually clicked on it, and it has some of the stuff when I was still there back in 2000, I believe, 13. So this group right here, putting a satellite transmitter, was actually the group that I was there with. Okay. Now we did ultrasound monitoring, so we're seeing how much these turtles are actually laying eggs. The sea turtles we're looking at were green sea turtles. Now we watched them lay eggs. We put a satellite transmitter on it, and me and my buddy actually from high school were the ones that found this turtle. So we actually got to name it and we got to track it. So this Dora, there's 5-day track here for Dora, is actually the sea turtle that me and my buddy found that actually got researched and got written a paper about. So that's pretty neat. Now, this kind of takes place in a couple different areas in Costa Rica, which we'll talk about more later. But in college, I did have another opportunity to actually go back to Costa Rica and do some of this again, but in a different respect. Okay. So in college, I ended up actually going out and catching sea turtles and predominantly looking for hawksbill sea turtles and looking for green sea turtles. Now, I don't have a lot of photos. I'm going to try to find some more, but for some reason, I just don't know where they are. But I worked with a professor or a professional. Her name was Dr. Beebe. I believe she's from Germany. She's a pretty young woman. But when we were there, we actually caught like 11 sea turtles and were able to tag them. So the sea turtle you're seeing right here and on this next photo is a sea turtle that we caught and we tagged. Now, the reason we tagged them is just to see where they're going, just to track them as they're going, because there's different research stations. Also to know if they're coming back to the same location every year. Now, is this data perfect? No, but is it a step in the right direction? Yes, because as many as you know, the sea turtle population is kind of starting to get threatened and is almost endangered just because of these facts that people are killing them for their eggs or people are killing them with their fishing nets. So there is some problems with these species. Now, with that being said, this one that we actually tagged here was actually tagged in the Galapagos Islands as well. Now, we did not figure out how old that tag was, but the researchers told us that it had to be pretty dang old because most of the numbers were worn off. So that's pretty sweet. Now, we also did catch another turtle called a hawksbill turtle. I wish you guys could see the back shell here. Maybe I'll pull it up quick. Let me just Google it for you. But the hawksbill sea turtle is a super cool turtle, but the problem is that their shell is really beautiful, okay? Which is great for them and great for us to look at, but the problem is people are killing them, taking their shells, and then making jewelry out of them. So this species population has drastically decreased. So we have to make sure they're staying preserved and try to stay safe. So they're kind of doing research on them to see where they're located, see where they are, and just try to figure out ways to help preserve this population. Now, as far as marine biology, that's about as far as I get. Okay, I know it's not a whole lot, but it is something. So let's talk about the ocean. Let's kind of get a couple of things in. It's not going to be a whole bunch of notes today, but we're going to talk about just a couple different aspects that I think we should start off with that are actually important. So the first thing is that we should understand, guys, that the ocean covers most of the earth. It's around 70% of the earth's surface is an ocean. Now, 97% of the water on earth is either sea or salt water. Now, you guys need to understand that every year we talk about how we have a shortage of water, that there's not enough water on the earth, blah, 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 things like that. Realistically, we have a lot of water, but the problem is we don't have a lot of fresh water. And for humans, we can't drink salt water, so we have to figure out a way to get fresh water. That's kind of where that disconnect happens, or that like conversation. Now, one thing that is pretty sweet about the oceans is that all sections of the oceans are connected, but all the sections of the ocean are also very different, but they do connect to each other. So if you look at the Pacific Ocean, you look at the Atlantic Ocean, they're connected. If you look at the Atlantic Ocean to the Indian Ocean, they are connected. Okay. The earth is round, so all these things do connect, and land doesn't have any complete blockways through the whole section of the world. So they're all connected some way, some interconnection. Now, there's a couple reasons, guys, why the ocean is super important. So it is an important source of food and mineral resources. So there's a lot of different places, guys, that use a lot of food from the ocean. Not so much in Minnesota. We don't eat as much seafood as other countries do, or other areas that are near the coast do, but it is important. Now, there's a lot of minerals that are found in the ocean, and those minerals we can harvest, and then we also still use. Now, we also use the ocean for transportation and recreation. Now, there's a huge industry, guys, for people that like put hotels next to the ocean, or they go fishing on the ocean, or they do like wake surfing on the ocean, or wakeboarding on the ocean, or like wake, what's that word I'm thinking of? Like, I don't even remember, but it's with like a parachute. Okay. But there's a lot of different things. Now, for transportation, a lot of people a lot of boats actually move products across the ocean. It's one of the most efficient ways to do things. So we put a bunch of cargo into a boat, and it just moves from one place to the other. And that's a lot of the way we get things from one place to one place. We can put a lot more things in a boat than we can compare it to a plane. Now, the ocean does store a lot of heat. So water has high specific heat, if you remember that from biology. So it takes a lot of energy to heat it up, and it also takes a lot of energy to cool it down. So water holds onto its energy, or holds onto its heat really well, and it will actually stay longer, and will keep the air around the ocean warmer for longer as well. So the stored heat in the ocean drives much of Earth's weather and causes climate near the ocean to be milder than climate in the interior of the continents. Now, in Minnesota, we kind of see this as well. So if you're up in Duluth, yes, they get a lot of snow, but they're also kind of in their own little microclimate. Because during the wintertime, when we might be super, super cold, Duluth's actually be a little bit more mild temperature, because they're still going to get warmer air off of Duluth in the winter. But now in the summertime, Duluth is usually typically colder, because they're still getting that cool breeze off of Lake Superior. Now, is this going to be in a big scheme when we talk about the ocean? Yes, because the ocean's way bigger than Lake Superior. But those big bodies of water do affect the climate of the areas that border them. Now, ocean currents do distribute energy, their heat, and their resources. So as energy kind of moves around, we're able to get those different heats. Guys, this is where the conversation we're going to end up talking about is with global warming. The ocean is drastically increasing, but it's only been by like 1, maybe 2, maybe 3 degrees in some areas. But remember, 3 degrees is a big difference. So if your body temp's at about a 98.6 degree Fahrenheit, if it increases by 3, now you're at about 101 degree point Fahrenheit, and you probably don't feel very good, and you're sick and all those different things. But the ocean, we're like, oh, it's only 3 degrees, it's whatever. But that's a big difference. So we need to be able to take that into consideration and realize that 3 degrees is a big thing. We need to talk about climate change. We need to make sure these things are taken care of. Now, what is the relationship between density and salinity? The only reason I want to talk about this, guys, is it's going to deal with a couple of things that might actually interest you when you guys get to your final projects in this class. So ocean water contains salts and gases, as most of you guys probably know. Ocean water has all 92 natural elements in it. And the term salinity is a measure of the amount of dissolved salt contained in water. Now, there is a bunch of different types of salt that is found in the ocean, but the most common one is NaCl, which is just sodium chloride, which is table salt. It's a salt that we use all the time. Now, salt water is more dense, is heavier than fresh water. So what this means is that when you're in salt water, your body should be able to float easier because the water is actually more dense. So it should keep you on top of it a lot easier compared to fresh water where it's a little bit harder to float. Now, density, guys, is a measure of the amount of matter packed into a given volume. So a whole bunch of salt in one thing of water should have a higher density than a little bit of salt in the same amount of water. Okay. Now, more salt, greater density equals more objects floating. Okay. Dead Sea is very dense, which we're going to talk about the Dead Sea a little bit as well. Now, just to give you guys kind of a visual representation of this, let me get my face out the way. In fresh water, do we still have dissolved nutrients? Do we still have dissolved salts? Do we still have dissolved gases? Yes. If you look at this, if we look at fresh water, we have maybe 1 or 2 dissolved liquids or dissolved solids in this. Ocean water is a little bit more, and the Dead Sea is a lot more. Okay, the Dead Sea is like super salty. Okay, it is more dense than ocean water. It's the most dense liquid, realistically, that we find naturally, besides in some like other extreme circumstances. But the Dead Sea water is relatively high in density and really high in salinity. Now, if you went to the Dead Sea, you would realize when you lay in that water, it'd be super easy to float because that density keeps you above. Now, when you go on something like Lake Beebe or like Beebe Lake, you hop in that water, floating in it, it's still possible, but it's a lot harder because the density of that water is not so high. So the more dense something is, the easier it is to float on top of. Next slide. Now, salinity and density vary in the ocean, different depending on where you are. Now, they are all connected, correct, but they don't share all the same water. They don't share all the same nutrients, all those different things. There is like spots where they meet and they break off from one another. And that's kind of why we have these different pieces. So higher salinity is going to be in your cold areas and your shallow areas because there's more evaporation. So in your shallow oceans, you have more evaporation. But remember, when we evaporate, we're not taking the salt out. We're only taking the water. So if you had a beaker like this, and I poured a whole bunch of salt in the bottom, and I stirred it all up, yeah, the salt would dissolve. Awesome. But when all those, or my bad. Yeah, salt will dissolve. Yeah. But when all the water evaporates, we'd still be left with the salt on the bottom. It's just how it works. If you've ever left like a can of pop out for too long, your can of pop will evaporate all the liquid out of it, but you'll be left with like that sugary, caramely, gross stuff on the bottom of it. That's because that shallow area is able to evaporate a little bit quicker, and you have a more noticeable change there. Now, lower salinity areas where ocean is diluted by fresh water. So there's these things called estuaries. And this is really where a river meets the ocean or where a lot of rain falls. But that fresh water mixing with that salt water is going to kind of make an area with less salt water because you're adding high density plus low density and kind of just mixing it all up. Okay, and it's going to give you just a difference when it comes to salinity. Now, I believe this is the last slide. It is. Okay. So what is the temperature of the ocean? The ocean is realistically going to be divided, guys, into 3 layers based on temperature. So there's a surface layer, which is the warmest, which is still going to vary by depth, but warm water is less dense and it stays on top. Now, realize that the reason that it is warmer is because the ocean is, or not the ocean, but the sun is penetrating that layer of the water. The closer you are to the sun, probably the warmer you're going to be. That should make sense. Now, there's also a layer called the thermocline, which the temperature is going to drop with depth. So if you look at this over here, it says about the first 200 meters of the ocean, guys, is roughly the same temperature. But after you get it past, like say, but this is probably around 300, my bad. But after you get past the 300 meter mark, it drastically decreases every single meter you get deeper. Now, there is still light penetration there. It just minimizes every single meter you go down. Now, when you get past roughly 700 meters, according to this graph, it's just cold all year. You get to deep water, it's cold all year long, and it's barely above freezing. So the surface layer all stays roughly the same, but then you have a thermocline, and then your deep water is super cold. Now, I know a lot of you are super interested in the deep sea and deep water, which we'll talk about because these creatures that live here have to be pretty well adapted for this. Now, for most of us, a lot of things we are interested in come from the surface layer. Are things like pretty fish and all those different pieces come from the surface layer, which we're going to talk about as well. Okay. Now, guys, this is realistically all we're going to get through today. Hopefully you took these notes, write them down in your notebook. We're going to talk about these. Other than that, that is all I have for you guys today. Make sure you guys watch this Edpuzzle. There's no Google form or anything like that. Have a good weekend. If you guys are going out deer hunting this weekend, please be safe. Please be careful. If you get any, send a picture my way. That'd be pretty sweet. Other than that, guys, have a good day. Have a good weekend. Bye.